Hello, everyone. This is David Dudas. I'm head of I'm VP of Video Solutions at Sorensen Media. Welcome to Cloud Slam, and welcome to this session, which is about hybrid video encoding, or the hybrid of on-premise encoding and transcoding with cloud-based encoding and transcoding. So we've got a presentation here for you, and just a brief agenda. Today, I'm going to give you a brief introduction to Sorensen Media, so you know who I am and so you know who my company is. Then we're going to take a look at video encoding workflows as compared to just a few years ago. Things have radically changed over the last few years, and that's really driving a lot of the interest and a lot of the need for cloud and hybrid solutions. Along those same lines, we're going to look at the explosion of devices, mobile devices, tablets, and so forth, as well as video formats that has been occurring and is still occurring. Another very important factor when we're talking about encoding is adaptive bitrate, so we're going to talk about that, help everyone understand exactly what it is and why it's important in this context. And then we're going to dive into comparing traditional hardware solutions, on-premise, transcoding servers, with the cloud, and we'll do some compare and contrast and see what the advantages are and the disadvantages are. And then we're going to look at a hybrid video encoding, how you can really marry those two together for a really unique solution. And then lastly, we'll talk about a case study. I'll tell you about what some of our customers at Sorensen Media are doing, and then we'll open it up to Q&A. All the Q&A will be written, so in your event panel, in the dashboard that you're using, there's on the bottom right, there's a Q&A section. You can type your questions there, and then at the end of the hour, we'll get to those and answer as many as we can. So moving into the first slide here, a little bit about Sorensen Media. So this is essentially some high-level milestones at our company over the last 15 years. We have been in business for over 15 years now, and some really significant milestones here in the context of video and online video. So starting back toward the beginning, when Apple first was releasing QuickTime, they licensed the technology from Sorensen Media. And then just shortly thereafter, a few years later, Macromedia, when they were putting video into Flash, they did the same thing. They came to Sorensen Media and licensed our technology to enable playback in Flash. We were the first codec technology used by YouTube. So right there, just with those three milestones, you can see that Sorensen has had quite a storied past and has played quite a significant role in the birth and really the evolution of video that's delivered over the internet. More recently, over the last few years, we've released Sorensen 360, which is our enterprise-grade online video platform. And in 2010, we took our award-winning Squeeze encoding engine, which has been in the market for 10 years as part of our Squeeze desktop solution, used by many enterprises, individuals, higher educational institutes, agencies, you name it, media companies around the world for 10 years. We took the engine from Squeeze Desktop and put it into Squeeze Server, and you'll hear a lot more about that today. And then just this year, 2011, we announced Squeeze Live, which is our live webcasting platform. So a quick quote here from Jefferson Graham at USA Today, a very well-respected technical writer. He says that every time you see a video online, you probably have Sorensen Media to thank. And just going back to those milestones, it's really, it's a great compliment. It's a great honor that people say these nice things about us. And I think you can see from the last slide that it's really, as a result of us being there at really key moments of innovation over the last 15 years. So moving on, I just wanted to throw this slide in here because I get asked this a lot, but basically what's the difference between encoding and transcoding? In this session, I'll probably use the words interchangeably. Most people do. It's okay to do that. So if you've ever struggled with this or if anyone's ever asked you this question, in practical terms, it doesn't really matter. People use the terms synonymously. Transcoding and encoding or compression are typically used interchangeably. However, technically there is a difference. So encoding is when you're beginning with a master, a raw format, an acquisition format, and then you're going to a compressed format like Flash or like QuickTime or Windows Media or MPEG-4. Whereas transcoding is when you already have a compressed format and then you want to convert it to another compressed format. So a little bit of a nuance there, but again, really nothing that we feel people should get hung up on. Again, you can use the terms interchangeably, and almost everyone does. So with that, let's jump into things. So what we're looking at here is just a really typical video encoding and distribution workflow around 2008, say 3-4 years ago. Back then, there was really one ubiquitous playback platform, and that was the PC or the desktop with Flash through a web browser. Flash really had that massive penetration that only very recently has been disrupted. We'll talk more about that in a little while. But the takeaway here is that encoding and distribution was pretty simple a few years ago. Mostly everyone did on-premise encoding. They pushed their output files up to a CDN or a host, and then the viewer was in their house or in their office on a PC connected to a wired internet connection or maybe Wi-Fi, but typically using Flash as their playback platform. Let's jump ahead 3 years, and now it looks quite different. So in terms of video formats, Flash is still, very ubiquitous. However, MPEG-4, AVC with H.264 has really proliferated, I think, beyond really anyone's expectations in terms of just how rapid it's accelerated and spread throughout the ecosystem. We also, of course, have WebM, recently open source and announced by Google, and they are hoping to make that a standard format for HTML5. Of course, you have Microsoft Silverlight with smooth streaming and WMV. MPEG-2 is used by Apple for streaming to iOS devices like tablets and the iPad and the iPhone and so forth. So right out of the gate, we have 5 times the number of popular formats that we did just a few years ago. And then if you look at the devices, sure, there's still the PC, the desktop, the laptop, but we have tablets, the iPad, the Samsung Galaxy Tab, the Motorola Zoom. We have Android phones, the HTC Incredible, the Samsung Galaxy, and then of course over-the-top set-top boxes like the Roku, the Apple TV. So really, if you look back and contrast where we are today and where we were then, there's just really been this explosion of endpoints, devices, platforms, as well as formats. And significantly, many of these platforms are not necessarily in a home connected to a Wi-Fi router. They might be on a mobile network using 3G or other mobile wireless technologies to connect to the internet. And that's important because if you are a content your or a content provider or service provider, and you need to encode video, transcode video, and prepare it for delivery to your viewers, your end user, your customers, because things have changed, you really no longer have a predictable, reliable guess at what their connection speed is. A few years ago, when it was a safe bet that probably nearly everyone was connected to a cable modem or a Wi-Fi router at home or in their office, you could, or DSL, you could guess that, okay, I'm going to have a connection speed here maybe around 1.5 megabits per second. But now with the proliferation of mobile devices like tablets and smartphones, many viewers, a very, very significant number of viewers are on wireless networks, mobile networks, 3G, Edge, soon to be 4G. So a big diversity in connection speeds. And that's where adaptive bitrate comes in. So for those of you that are familiar with the term but maybe not exactly familiar with how it works, Adaptive bitrate is a technology that essentially exists for, you know, if I can really generalize, it's to solve one problem. It's the buffering problem. If you've ever watched online video and you've had that frustrating experience where the video stream pauses unexpectedly and you see the icon that says buffering, and then it starts to play again, and then it might stop again, and you have this frustrating experience, that experience is caused by bandwidth conditions. So you may be connected to the internet over, let's say, a Wi-Fi network, and 1 minute your bandwidth might be great, but then if somebody else on the same network starts downloading large files or uploading large files or doing something intensive on the network, it's going to negatively, adversely impact your connection speed. And that's really what has always caused those buffering issues in general. I mean, there are other factors, but let's keep it high level. So now that the environment, the network conditions are so varied in this modern landscape, adaptive bitrate really is a must-have for people encoding and transcoding video for delivery. So let me tell you how it works. It's really quite simple. You've got a player, so maybe you're using your iPad, which has a media player built into it, or an iPhone, which also has a media player built into it, or an Android phone, or any device. You know, all the devices have the players in one way or another. And when you start watching, let's say you watch a 2-hour movie, in the old days there was literally a 2-hour movie in one large monolithic file on a server, and that would start streaming over the internet. Well, now what happens with adaptive bitrate is your player on your device, every 5 seconds it will measure the quality of your bandwidth connection, and then it will call the server and it will say, hey server, I need another 5-second segment of this movie I'm watching, and by the way, I just measured my bandwidth. I'm currently able to receive 800 kilobits per second, for example. And the server responds and says, okay, here's your 5-second segment. You know, this segment is perfect for an 800K connection. 5 seconds later, the same thing happens again. Your player measures the bandwidth, contacts the server, reports the bandwidth quality to the server, and the server replies with a 5-second segment that is adequate, that will make it through the pipe to you. So you can imagine that encoding and transcoding video for adaptive bitrate delivery is more complex than it used to be. You know, referring back to the earlier slide with that typical workflow, really you had one input file, and then you put it through your encoder, and then you typically had one output file, which was an FLV or a flash file in many, many cases. But now, if you need to encode for adaptive bitrate, here's how you do it. So step number one is you really need to determine the number of bandwidth connection speeds that you want to support. Best practices suggest that you support around 10 connection speeds, and you can see here, and this is what we at Sorensen Media recommend as well. You can see an example. I'm going from 200 kilobits up to 2 megabits per second. That's a pretty wide swath of bandwidth connection speeds. Of course, you can do more, you can do less, but generally this is what's recommended in the industry. So now that you have identified that, okay, I want to support 10 different bandwidths, you have to take your source video and you have to chop it up into a bunch of 5-second segments. No longer will you have one 2-hour video file on a server. It will be, again, chopped up into many, many 5-second segments. And then each one of those segments has to be encoded at different bit rates. So you'll see down at the bottom right, I've got a picture here, some icons to illustrate that the movie starts at a time code of 0, and then there's the 5-second time code, the 10-second time code. It's going to go all the way up to the 2-hour time code. And for every one of those time codes, you'll see I have 10 renditions. So at the 0 time code, I've got a 200K rendition of that 5-second segment, a 400K rendition, and so on and so on. So what does that add up to, and how does it really impact your transcoding needs, your encoding needs, your infrastructure needs? What kind of real-world impact does that have? Well, let's look at the economics of that last example. If you take a 2-hour source file, 2-hour movie, and you want to prepare it for adaptive bit rate delivery with support for 10 bandwidth speeds, first you take that 120-minute video, you divide it into 5-second segments. That gives you 1,440 segments. And then, like we said in the last slide, those 1,440 segments each need to be encoded 10 times to support those different bandwidth conditions. Therefore, bottom line, and this is a shock to people when they first learn it, that for a 2-hour movie or for every 2 hours of source content, you need to store and encode over 14,000 digital files. So I'm going to just pause. Think about that for a minute. So we've gone from, a world where a typical workflow, encoding workflow, meant one input file typically mapped to one flash output file. Now we've evolved to the point where one input file can get you over 14,000 output files. So clearly the transcoding and the encoding requirements are complex. Actually, the know-how to do this is fairly complicated. And of course, there are storage needs, a lot of implications here. And lastly, lest I skip this, this is really important, that's just for one format. So if I went through this exercise and I encoded my 2-hour movie and I ended up with 14,000 files, they might play great on an iOS device, on an iPad or an iPhone or another Apple product, but guess what? What if some of your customers are using Silverlight? Those files aren't going to play. Or if they're using Flash, those files aren't going to play. So again, this is another consideration. Really depending on your assets or your business model or your customers, there are a lot of factors that go into it. But bottom line is that you need to determine: are you encoding for Flash? Are you encoding for Apple? Are you encoding for Microsoft? Maybe you're doing all three. There's also Android that comes into the mix. So you can see, the encoding needs for adaptive bitrate can really, really add up and create some serious complexity. So the question becomes, how do you prepare for that type of environment? What type of infrastructure do you need? What kind of technology do you need? So what we're going to talk about here is, and this is a little bit of a complicated chart, but I'm going to walk through it. So what we're looking at here is, let's focus first on the red line. So let's say that, having learned what you just learned, you understand adaptive bitrate, you understand that you need to encode for all these different formats and different devices in the market. So you understand that your transcoding needs, are really a lot different than they were just a few years ago. And let's say you need to prepare for that, or maybe you're building a new business or a new business model that requires delivery of online video. So, the old school way is hardware. On-premise hardware, buy your own servers, rack and stack your servers, configure them, run them, have your own IT infrastructure. So going back to the chart here, the red line essentially illustrates unpredictable demand for encoding needs. And what I mean by that is that encoding and transcoding is typically difficult to predict. You have spikes, you have peaks and valleys. It's never a straight line. It's never a straight curve. So what you find yourself doing is trying to provision hardware to meet that demand. So now look at the blue line. There's a step function here. And what this illustrates is, you'll have some hardware. You've got some servers. Maybe you have 10 servers in your data center or your colo or in your building. You provision some servers, and then now you have maybe 15. But in any case, the growth isn't instantaneous, right? There's a delay. You have to order servers. They have to be shipped. You have to unbox them, configure them, rack and stack them, and so forth. So what you end up running into is a situation where your demand curve is not necessarily going to be in parallel with the infrastructure that you have suited to meet that demand. So the bottom line is that you're going to find yourself in one of two situations. Either you're not going to have enough capacity, you didn't get enough servers, the new servers haven't arrived yet, you just had a spike in transcoding needs, but you do not have the capacity. Therefore, you're not going to be able to meet your business needs. Or, in other words, you have too little capacity. Or the opposite of that would be you bought way too much, you bought a ton of hardware, and it's sitting there idle because you essentially overinvested. So that, in a nutshell, is really one of the core problems with the hardware provisioning model. Either you have too little hardware or too much. You're either unable to meet your business needs or you're spending too much money. Just to summarize most of the things I just said, so it's really impossible to accurately forecast encoding demands. It's a spiky business. Peaks and valleys can be very unpredictable, not linear growth in really any cases that I've ever encountered. If you want to make sure that you always have enough capacity, you're really going to have to invest, capital in that. And of course, nobody running a business wants to unnecessarily spend their capital. And of course, the opposite, which we've already covered, means you will not have sufficient capacity. Significant lead time is one of the issues here. One thing I didn't really mention is the complexity in coding, but I think we covered that with the adaptive bit rate. But real briefly, and this goes in the next point too, the cost of doing it wrong. Real briefly, encoding is complicated. Not only are there things like adaptive bit rate, but there are a lot of variables that really are kind of a black art or a black science. When you start to look at frame sizes and codecs and codec profiles and data rates and multi-pass versus single pass, key frames, B frames, there are a lot of very important variables or dials and knobs, if you will, that can either make or break your quality. So when people dive into video encoding, they try to do it themselves. Usually the first problem that they run into is, wow, I really don't understand any of this stuff whatsoever. So that's another one of the issues with the do-it-yourself on-premise approach. And then, of course, just the costly IT infrastructure and overhead. It costs money to keep those servers in racks and keep them cool and run power to those cabinets and have bodies on staff that can wake up in the middle of the night if a power supply dies and they have to go to the data center to swap out a server if you're running a 24/7 operation. So some of the considerations with traditional hardware. By means of contrast, let's go to this next slide. And what this illustrates is that with transcoding and encoding in the cloud, you can have your provisioning actually reflect your demand. So with cloud servers, with cloud computing, I'm sure you've heard a lot of this this week in the Cloud Slam, so I won't spend too much time on it. But bottom line is that, as opposed to the traditional on-premise model where all of a sudden you run into a spike in volume, you have a huge transcoding job or set of jobs to do, but you don't have the hardware, and it's going to be 6 weeks until the boxes show up. With the cloud, especially with some of the automated scaling solutions, such as the ones we have at Sorensen Media and our partners RightScale employ, you can set up business rules so that when your demand exceeds your capacity, you can automatically have servers deployed nearly instantaneously so that you're going to have an infrastructure in place on demand to meet your demand. And then when you get past the spike, when your demand diminishes back down to maybe a baseline level, again, those business rules can automatically take servers out of the mix and wind them down to save you money. So some of the benefits of cloud provisioning, just to reiterate, so no CapEx, which is nice, right? You can log into a dashboard, press a few buttons, and you've got servers on demand. Again, I'm sure that's a theme that's been pretty common this week at the Cloud Slam. Lower OpEx. So with the cloud, especially cloud transcoding servers and encoding, many of these solutions, including solutions from Sorensen, are managed solutions. So, if you run into a problem, if an encoding job fails, or if, a power supply dies or disk drive dies, since this is since there are fully managed solutions available, these things would never really appear to you. It's managed. It's all behind the scenes, and you essentially have virtual IT staff that's taking care of all the headaches for you. So the bottom line is that's going to lower your OpEx by requiring fewer bodies to manage your infrastructure. Next point, scalability and elasticity. I think we've covered that really well, but that's obviously one of the key value props of the cloud. When I need more horsepower, I can have it on demand, and when I don't, I don't need to pay for it, which ties right into faster deployments. So really, we're in this awesome environment. I could say that as an entrepreneur who's built businesses before, including colos with lots and lots of servers in them. The deployment times are just mind-boggling for those of us that have had to set up physical infrastructure before. Literally log into a dashboard and press some buttons, and you've got computing power. And maybe that is stated the obvious, but I think in this context it's worth saying again, because transcoding and video encoding, transcoding, it's probably the most CPU-intensive thing you can do. So the fact that you have this really significant horsepower at your fingers to do something so resource-intensive at video encoding, to me, I just think it's a great thing. And then encoding expertise. Again, we touched on this, but if you're setting up your own stuff, you're going to run into the situation, unless you're an encoding expert, you're going to run into the situation where you don't know what the variables are, you don't know what they mean, and if you pick the wrong one, it's going to make your video look less than not as good as you want it to. So what's great, in my opinion, is that you have companies like Source Media and others in the space who really are encoding experts. So what we're doing is we're putting this expertise in the cloud and making it available via API or via dashboards. So really, you don't need to understand what the different parameters are. You would essentially tell us, I need my video to play on the iPad, and I want it to look great. And we say, okay, we got you covered. Or Android, or a set-top box, or a smart TV, or a competing tablet, or competing smartphone. So really, what we're doing is we're trying to take all the complexity out of it and just make the end results beautiful, but make them available to you without you having to, really going through those difficult learning curves. And then lastly, service level agreement with encoding experts that are offering services in the cloud as a managed service. For example, at Sorensen, we offer a 99.9% uptime guarantee in our service level agreement. So that can take a lot of risk out of your business. If you are going with, your traditional hardware on-premise model, hardware fails, it's going to fail. So, you can really maybe lose less sleep at night knowing that you're using the cloud and that the SLA is going to protect you against outages. So let's move on to really maybe the salient point here for this presentation. What is hybrid video encoding? So I've tried to really simplify it and not draw a diagram that's too crazy complicated, but I think I've essentially captured it in its essence. But starting from the left and going left to right, you have a lot of source files, and via an API, you put them into a job queue. And a job queue is essentially, well, it's a queue, of course, but it contains things like where's the source file. Maybe you upload your source files, or maybe you have them on an FTP server, or maybe you have them on a LAN, or some network-attached storage. Maybe it's on a website, or there's an HTTP location. Maybe it's in an Amazon bucket. Your source files can really be anywhere in the world, and cloud and hybrid encoding solutions today can fetch files from just about anywhere. So the job queue will contain, okay, where's the source file, and what do you want to do with it? So do you want to output one FLV, or do you want an FLV and a QuickTime and a Windows media file, or do you want all of the above in adaptive bitrate, or do you want encoding for iPads and iPhones and Galaxy tabs and Zooms? really all the, the output devices and profiles and configurations are stored in the job queue, and then typically, and I'm kind of keeping it simple here, but typically the last major thing that's kept in the job queue is where do the files go after they're done being transcoded. So for example, with Sorensen solutions, we can really publish anywhere. Maybe you want your output files to go up to your CDN, Akamai or Limelight or CloudFront or EdgeCache or Highwinds, or you want it delivered to an FTP location, or maybe you want to send it to a client for review and approval. Bottom line is that the job queue really encapsulates the entire transcoding job. And what happens next is that part of the solution is the set of business rules. Remember, in this hybrid environment, the business rules will essentially say, okay, I'm going to pull a job out of the queue, and where should it go? Should it go up into the cloud, or should it stay on-premise? So I'll give you some examples of how this comes into play. So let's say I've got a hybrid environment set up, and I've got some servers on my site in my building, and they're running Squeeze Server, our enterprise server-based transcoding software. And then I've also deployed the cloud for overflow. So a typical example of hybrid video encoding could be I usually run most of my transcoding jobs through my on-premise servers, but I have an SLA that I have to meet for my customers, so I never want my jobs waiting longer than 5 minutes. Meaning if I put a job into the job queue, within 5 minutes, one of the servers should pick up that source file and start transcoding it. So I can set up business rules that say, if my job queue, if the wait in my job queue ever exceeds 5 minutes, spin up some servers in the cloud and start using that for excess capacity in real time to push my overflow up there. So now what I would be doing is I would be essentially taking the load off my on-premise encoding, or maybe a better way of saying it would be throttling how many jobs can go to my on-premise encoding servers, because I know how many servers I have and I know how much they can do. Or I can set up business rules to figure that out for me. But in any case, the system knows how much the on-premise servers can do, and when it realizes, hey, these servers, these things are melting steel right now, there's burning through jobs and there's no end in sight, but the business rules can automatically start sending some of the jobs to the cloud. Another example would be if you have really diverse or variable file size for input files. So let's say maybe you have 1 and 2 hour movies that you're encoding, but you also do a lot of 1 and 2 minute webisodes or trailers or segments. One use case for hybrid video encoding would be those really large files. It can take a long time to upload them, so some customers choose to use their on-premise encoding for the very large files, the very long duration videos, and then the shorter ones they'll push up to the cloud, which is a good way of economically, essentially load balancing your encoding needs across 2 different environments. So when to utilize hybrid encoding. So I've covered a couple of use cases, but to drill down a little bit, what we're seeing at Sorensen is that many customers already have on-premise hardware. Sure, it's a sunk cost, but no one wants to really throw out a room full of servers if they have them and they're functional and they have some lifespan left in them. So if you already have on-premise hardware, but it's not meeting your capacity requirements, a hybrid model is a really good fit in most cases, because clearly if you don't have the capacity you need, you definitely need more, but maybe the CapEx is an issue for you, or you don't want to build out your server room anymore, or you're hoping to migrate eventually. That's a really good opportunity to use the cloud to supplement or augment your hardware solution. Dynamic scalability, I think we've covered that really well, but that's when you have excuse me, when you have unpredictable volume, the hybrid is a really good solution. If you have really predictable volume, if you know you're doing 100 videos per week and every week looks like the last, then maybe that's not the right solution for you. But in most cases that I've seen, and really just about every case I've ever heard of, that's rarely the case. Usually the volumes are very spiky. Extreme variance of source file size, we talked about that on the last slide. And then desire to migrate to the cloud. So at Sorensen, we talk to a lot of customers, a lot of prospects that have their own hardware on-premise infrastructure, and maybe it's outdated, maybe it's outmoded, maybe they're tired of maintaining it, whatever the case may be. Many out there today want to migrate from on-premise solutions to cloud solutions. However, they still have their business to run, and no one really wants to interrupt, their day-to-day operations. So rather than going whole hog and just trying to convert overnight and migrate everything like on-premise encoding to cloud encoding, the hybrid model can be a really great way to incrementally migrate. So you have your on-premise servers, configure those to work with some cloud transcoding infrastructure, and then over the course of time, you can gradually decommission your physical servers and move more and more of your jobs up into the cloud until eventually you phase one out and you're 100% on the cloud. And then lastly, I think I've touched on this, but really again, to underscore, encoding is very complex. It is certainly not something that you can set up and then just leave it and forget. Think of it like an Outlook server. There's a guy on your IT staff that manages your mail system, right? And if he's not there, it's going to be an issue. So encoding is the same way. Things go wrong. It's complicated, and not only that, but the industry's moving so quickly right now. We have these new formats. WebM. We've got the new adaptive bitrate competing formats, smooth streaming and HLS and dynamic streaming, new devices that play different profiles. So really, if you have your own encoding infrastructure and you need to continue to update that to keep up with the emerging trends, the emerging platforms, it can be a serious full-time job for a significant number of bodies. So if you're just tired of that complexity and you can't keep up, I was in Hollywood a few weeks ago meeting with a studio, and they have a very robust in-house encoding system, but they said quite frankly, you know what, we're really tired of trying to keep up with all the changes. The industry's just moving too fast. So that's a good example of where moving to the cloud can make a lot of sense. I want to just pause here. We have about 20 minutes left. I see that there are some more participants that have joined, so we're going to have Q&A at the end. So now would be a great time to enter any questions you have into the box in the meeting interface. And I've only got, I think, a couple more slides, maybe one more, too, and then I'm going to start answering questions. So if you have any questions, please enter them now, and we'll get right to those. Okay, moving on. For a case study, one of our customers here at Sorensen Media is Technicolor. So I think everybody's very, very familiar with Technicolor. It's a household name. I believe they've been in business for 95 years, doing production, post-production in Hollywood for feature-length films, for television, dramas, sitcoms, daily episodes, everything. So very, very well-respected name in the industry. They have quite significant encoding needs, as you can imagine. And they had a problem they needed solving just last year, and they came to Sorensen to see if we could help, and we said, absolutely, that's something we would love to help you with. So that something is called ShareView, and it is a digital daily solution. And for those of you who are unfamiliar with digital dailies, let me walk through it for you. So Imagine you're on set at production. Let's say it's a feature-length film that's being produced. Maybe it's being shot on the East Coast, New York, and the producers are back in LA. Well, every day, whether it's a feature-length film or a TV series, in any case, there are always dailies. And dailies are essentially a rough cut of the day's shots that get reviewed by the director, the producer, the DP, the showrunner. Anybody that's involved or any of the executives involved in the production, they see dailies. And typically the way it's done, especially with remote shooting locations, is at the end of the day, the editors will get the footage together, they'll burn DVDs, they'll call up UPS or FedEx, the truck will come and pick it up, they'll overnight it to LA. The next day, they wait for the delivery, they get the package, they pop the DVD in their DVD player, and they watch the dailies. And then if they have feedback, then of course they have to capture that, get that sent back to New York. So, if you think about it in terms of this crazy modern world we're living in, that's really just a really archaic workflow, right? Especially with the internet and the ability for us to transfer data around, with this really amazing technology that they have these days. So what Technicolor wanted to do is create a digital daily solution. Sorensen, we built it for them. It's powered by our Squeeze solution pack, and it's called ShareView. And here's how it works. Imagine you're on set at that shoot, like let's use the same example, you're on set in New York. Every day at the end, when the editors are getting the dailies together, they still go through that process, but now instead of burning to DVD and calling the truck to pick it up, they export straight out of their Avid or their Final Cut. We have a plug-in that goes into the editing bay, and the plug-in essentially uploads the dailies to the cloud, to the Squeeze solution pack. We use Aspera. Our partner Aspera supplies us with fast file upload. So this is, quite honestly, this is something you have to see to believe. If you've ever uploaded a large file to an FTP server or a video to YouTube, you know it can take a long time. So you're probably wondering how on earth could, Hollywood be uploading, very large HD files for digital dailies. Well, the answer is Aspera. Aspera has some fantastic technology that significantly accelerates upload speed. You can experience improvements from 10 to 100x over just normal uploads over normal bandwidth conditions. So it's really, really amazing. So with ShareView, the editor's in his bay. He clicks a button. All the HD footage gets uploaded to the cloud. And then from there, our solution, we scramble it, we wrap it in DRM. Remember, these are movies or television shows that are in production that have not been released yet. I'm sure it won't be lost on anyone that Hollywood is extremely obsessive about secure. They don't want things showing up on peer-to-peer networks or on YouTube, especially if it's maybe a premiere episode of the popular show for the fall season or a new movie coming out, next year. So we wrap everything in DRM, we scramble the content, and then anyone that's associated with the production, they have to have an app installed on their Android device, on their iPad, on their iPhone, or we have web-based interfaces as well. But a registered user, once the files are uploaded, they'll essentially get alerted, and then in real time they can watch the dailies right on their iPad. So, just imagine what a leap forward this is for Hollywood. Used to waiting a day to see the dailies for remote shoots, now they can see them the same day. Ironic, because they are called dailies, right? So, but they can see them the same day, and they can see them on their iPad at Starbucks or wherever they happen to be. So, really, really a very fun project that we worked on. Really honored to be working with Technicolor. And frankly, really, really happy to be involved in, some cutting-edge technology in Hollywood. The industry is really embracing technology. It's really been, a tape-based workflow in Hollywood over the years with a slow and steady migration towards file-based workflows. But with the recent disasters in Japan, many of the tape factories have actually been destroyed, and there's a severe shortage of tape in Hollywood. we actually started working on this project before that, but suffice it to say that tapes are in rare demand. Hollywood is feeling the pressure. They're looking to accelerate, migration to file-based workflows, which, by the way, obviously works really, really well with cloud and hybrid models. So we're really happy to be a part of that. I want to mention RightScale. RightScale is our partner for scaling. So you've heard me talk about Squeeze Solution Pack and some of our other solutions. When you have business rules set up that essentially add virtual servers to your configuration, a lot of that is done with our partner RightScale. So great company, great people doing really innovative things, but essentially our platform runs on top of Amazon Web Services, AWS, and then we use RightScale to automatically grow and expand and shrink our transcoding and our encoding infrastructures on demand automatically in real time. So quite a partnership here that we're really happy with. So with that, I believe that is my last slide, except for one last pitch for Sorensen. What we do is we provide video encoding solutions. So whether it's, if you are seriously considering, implementing, server-based transcoding, whether in the cloud or on-premise or in a hybrid model, that's where our expertise is. We have been in the biz for 15 years doing some really innovative things. We continue to do so today. And we really love to solve problems for our customers. So, to the extent that you need any custom solutions built or you need guidance on how to implement best practices for encoding solutions, we are, would definitely ask you to consider us as you go through the paces. And with that, I'm going to take a break here, short pause, and allow for questions to be entered. And then I'll be back in 30 seconds and answer some questions. Okay, we're back. We actually have had no questions yet, so we've got about 10 minutes left. The presentation is done, but I'm going to stay on the line. If anybody has any questions, I'll stay on the line for the next 10 minutes and be happy to answer those. So if you have any questions, please enter them now. Otherwise, thanks for joining.